Hi all, welcome to this presentation. My name is Dr. Tariq Umar and I am going to present our paper and experimental investigation on strength characteristic of concrete using waste paper sludge ash. The content of my presentation include the introduction and the problem statement, then the research methodology in which I will explain the laboratory experiment. Then I will discuss the result and analysis, and then we'll have a conclusion and recommendation for future work. So we all know that concrete is one of a major material which is commonly used as a construction material in the construction sector. It is a preferred material because it has different good properties considering its strength and durability. But on the other side, there are some environmental issues because the environmental impact of concrete comparatively is high when we compare to other material. Cement is one of the main element to produce concrete, and when we produce 1 ton of cement, we roughly produce the same amount of carbon dioxide, and the same time there is also emission of SO2. The main reason for this high emission is that when we produce cement, so we utilize a huge amount of energy, which also make the cement quite expensive. Um, and therefore, the researchers are trying to investigate and adopt different alternative materials which could be not only environment friendly but can also reduce the cost of concrete. So if we look at the example of China and India, so they are the world leading producer of cement, but at the same time they are also leading the environment polluter in the world as well. Because the earth population is increasing, so the cement demand in future will be double in the next 30 years. So if we adopt some supplementary cementitious material, we can not only meet our cement requirement, but we can also reduce the energy CO2 emission, and we can thus protect our environment. There are several material which has cementious properties, and one of them is the waste paper sludge. The waste paper sludge normally goes to landfill, and it is also recognized as one of the major contributor to the air pollution. Paper sludge is classified as class 2 liquid alternative fuel, and if it is burned, the fly ash consists of the same property as of Portland cement. And if we utilize this fly ash, we can produce low cost cement, which can also be environment friendly. And the reason for that is that the waste paper sludge ash is very high in calcium chloride and also contain minimum amount of silica. So the blending of this ash with the cement in the presence of the water result in the chemical reaction between calcium hydroxide and with the hydrated Portland cement, which in the result produce calcium silicate hydrate. So we have used that ash powder in concrete to see its performance. M30 concrete was made with different percentage of paper waste from 0 to 40%. The ordinary Portland cement was used in the experiment, and the waste material, the ash, was obtained from the University of South Wales. Here in the table, you can see the composition of the cement and the hypo sludge which we have used in our experiment. Like for example, if I just look at to the first item, the limb or the calcium oxide. So in cement we have 62%, and if we look at to the waste material which we have used, that has 46.2%. So it's not quite equal, but roughly they have the same content. So apart from using Portland cement concrete and the waste paper ash, we have also used coarse aggregate, fine aggregate, and the water, which are the normal ingredient for a concrete. We have produced and tested 50 cubes of concrete, 10 cylinder, and 5 beams. And the focus on our laboratory test was on compressive strength, split tensile strength, flexural strength, and water absorption test. The water cement ratio to produce the samples was 0.6, and the sample were placed in water tank for curing for the required number of days. Here is the detail of the samples which we have produced. So here you can see the description of the cubes, the 50 cubes, and the percentage of the waste material which we have used, the ash, and then the number of the cylinder which we have produced, and then the number of beams which we have produced with the different percentage of the waste material. 15 cubes were tested after 7 days to check its compressive strength. The remaining cubes were tested after 14 and 28 days. For water absorption test, the samples were kept in the oven for 24 hours at 110 degrees centigrade. And in the tables, you can see the mix proportion where you can see the ash percentage. The water cement ratio was same for all the samples, and then you can see the cement, fine aggregate, the ash which we have used, the coarse aggregate, and we have also tested the slump values for that. So let's look at to the test result, and the first one is the compressive strength. So as you can see in the table, the compressive strength basically increase when the percentage of the waste paper ash increase, but this increase is only up to 30%. If you increase the percentage of the ash more than 30%, then the compressive strength basically reduce. This is applicable on the strength on 7 days, 14 days, and also on the 28 days. So here what you see is the graphical representation of the compressive strength. So as you can see, when we increase the percentage of the waste paper ash, so the strength basically increase on 7 days, 14 days, and 28 days. That go up, that continue increasing up to 30%. But when we increase the percentage of the ash, then the compressive strength decline. The situation over the split tensile test is totally different from the compressive strength. So here from the graph, you can simply see that the tensile strength basically reduced when we increase the waste paper ash. The same thing happened with the flexural strength as well. So as we increase the waste paper ash, the strength basically reduces here as well. In terms of the water absorption test, the result indicate that the water absorption increase as the percentage of the waste paper ash increase, but that is only up to 30%. When we increase more than 30%, then the water absorption basically reduce. So from this study, we conclude that waste paper sludge ash has a positive impact on the concrete compressive strength, but there is a negative impact on the split tensile strength and also on flexure strength. Water absorption also increase with the use of the waste paper sludge ash. So clearly we can use the waste paper sludge ash where we just encounter only compressive strength, and it can also help us to reduce uh, the cost of the concrete and can also help us to reduce its environmental impact. Further experiment can be done by mixing waste paper sludge ash with some silica admixture. The use of gypsum, lime, and other material can also be investigated, and the sample can be tested for a greater number of days. Finally, here is a list of references that has been used in the study. Thank you very much for your attention. Here is my email address. If you have any question, please get in touch.